I'm back. I cheated slightly. I mean, first of all, I revised what a heap was. I loved the video by, I think it was Michael something. It was like heaps in 3 minutes or 4 minutes, and heaps in 6 minutes. He like explains data structures like BFS or even algorithms like BFS in like 6 minutes, DFS in 6 minutes. I would check that out. I love the brevity of his videos. And then I went over and watched the Kth video for this as well. I thought I would struggle a little bit. I pulled up the documentation for heap queue. This is the way to build heaps in Python. It seems like I've seen Nico do it twice now, so I think it's probably the way to go about doing it. Smallest element is always going to be at 0. I thought heaps were like they began at 1 though. Let me read this. Okay, sure. So we're gonna need heap push, where we have the heap, push the item. This would be log n time, because you would probably need to go down the height of the tree and add it in there. Heap pop, if you want to pop from the heap, which we probably did. We have a list, so we want to transform that list into a heap. In linear time, interesting. Okay. Okay, so the strategy that I was told. Let me pull it up. Yeah, drawing. Hold on. So we have a heap. Or so we have, you know, whatever, you know, I think a nearly complete binary tree works. And then you have a list, right? But then we talked about we talked about the elements of the list if you add it in between, right? And that's one way to go about doing this question, because you need to, yeah, the Kth highest score. So first of all, if you get like a array, like I don't see an example here, so I'll just make an example. 2, 3, 2, 5, 6, 3. I think you have 2 again. Yeah, you have duplicates, so just like put that there. That. And if you try to like so we know, and if we imagine that k is 3, we know the answer in here at the moment is, so we start at 6. Well, first of all, you want to sort this, right? So you sort this, you get 6 over here, 5 here, and then 3, yeah, 3. And then that's all we really need, because the trick to this, I mean, first of all, so 3, right? So you need to sort it, so that's already n log of n time, right? Because that's the amount you need for sorting, n being the number of elements in this array. And then you also need to like go in and add it, right? Add the what's it called? When you add an element, you have to add it into the appropriate place. And if you insert an element in an array, it can be worst case O of n time, n being the number of elements in this array. So that's already one thing to consider. But if we turn this into a heap, well, first of all, we don't really need the 2's actually, because we only add to this element, right? So if we add, like, if we add a 2, it's just going to be somewhere down here. A 1, that's somewhere down there. But if we add like an 8, well, there we go. So now we keep this and just actually remove this. Like, we're always like having like a cutoff point somewhere here. Like, we don't really need these elements down here. Can I undo all this stuff? Ah, I can. Nice. Yeah. So like a cutoff line. So that's the idea. Anything I'm missing? So I don't know if that changes our algorithm to like a log of k now. Maybe it does. Do we still need to sort it? Like, well, it says here that heapify transform lists into heap in linear time, so it is gonna be n, like we are already gonna have O of n right time complexity, and will it be more than O of n? Hold on, let's take a look at this. So we build a heap, right? That's O of n. Okay. Build a heap, O of n. We know adding can be log of k because it won't be log of n. Like log of k can be worst case n, but like I think it was, I forget the restrictions on the k, but it was like bounded by n in some way or form. So technically log of n. Yeah, but still, this is the has a, like, this is the one that's supported, and we can kind of ignore the log of k because this is asymptotically more significant. I don't know if that's the right terminology, but then Nikud was saying that it's actually n log of n. Why is it that? I forget. There's some case for that. Yeah. Space complexity would also be O of n because we're storing a heap. But how's that different than just inserting it into the middle? Because that's the same time complexity. Maybe they just wanted us to use a heap. I don't know. Interesting. All right. Well, I'll get to the question. So first thing first, I didn't realize like these member variables were defined like you can like define it like this, and then you can define like a new one as well. Like I thought you have to like define it up here, like a min heap or something. I know in Swift you do like min heap and like var, and then you like if you don't assign it a value here, you have to assign it in the initializer. That really threw me off in like the Uber interview. I was just struggling like for like a solid 5 minutes trying to figure out why it wasn't working. I also forgot the self. That's just kind of embarrassing, but it's okay, whatever. So we have a min heap, num. So we actually want to call heapify. Do I need to import anything for this? Well, we'll see if we get an error. So heap q dot heapify. I also don't get what a priority queue means. Like, how is this a queue? Oh, it's because it's a min heap. If you pop from the top, oh yeah, we're doing a min heap the other way. I didn't explain why. But hold on. So if you pop from the top, because it's gonna pop up the minimum element, and that's just O of 1 time because you have like reference to like the root. What was I trying to get to at that point? Define nums. I'm having a brain fart. Okay, I forgot. What in the world? I completely forgot. Okay, well let's get back to min heap then. We're doing a min heap. Exactly like the point I mentioned about popping. When you kind of get to a stage where you add like an 8 and then you no longer need a 3, you can just like pop it off. And with the min heap, you want to be popping off the middle values. Sorry, the lower values, the values that are no longer needed. So that's important. Also, I guess while the length of min heap is greater than k, we want to like pop from it. I don't know if heap pop will solve it. Will it solve it? I'm also not, like, I should probably do self.minheap and self.k and self. There's so many selves. There must be a better way to do this. So pop like that. That's so simple. And that's O of 1. Tiny complexity. Pop and return the smallest item from the heap. Retain the heap invariant. If the heap is empty, index error is raised. Oh. Okay, well, I think this guarantees that I won't pop it empty. So I think we should be okay. K, the restriction with K was it can be lowest it can be is 1. Cool. Heap push pop. So I think that's it. And then here, you want to add, so you want to do heap q dot heap push. Was that it? Heap push, yeah, and then heap and the item push. So you want to push self dot min heap. You want to push 2. This is the heap you want to push 2, and you want to push this value in. And then you want to also pop the like the smallest, like I mentioned here. If you add an 8, you want to pop the 3, right? And I think you just self, yeah. It automatically assumes. It automatically pops from the top. I guess that's what makes it a priority queue, because the queue is like first in, first out. So the first element, like the one at the top, is like the one that's like popped off, and then that's O of 1 time complexity. Like to remove that, usually if you remove from a list from the beginning of the list, that could be up to like O of n, just the way lists are structured in memory. That was also the point I was trying to make when I was explaining the heapify thing, the point about priority queue. So I'm glad I came back to that. So now there's a slight edge case here, because what if we don't have more than, like, what if like this is so let's take, come down here. We have 1, 2, 3, 5, 6, 8, right? And let's imagine that k is actually like 10, right? So this is a problem, because if we pop, well, this list right here, it's 1, 2, 3, 4, 5, 6. It has 6 elements. Why are we popping from it when it's the 10th largest element would be the lowest one, right? 1. Would it be 1 actually? Yeah, maybe this is a different edge case. But like, so considering this, we don't want to be popping. So the edge case to consider here is while while the same thing from here actually. You only want to pop when it's greater than k. And then we do want to return something. We want to return this. Or no, we want to return the Kth largest element, which should be this, and it should be self.that, because we saw here the smallest element is always the root, and we know the smallest element will be at the root. We know the Kth largest element will be at the root because we only keep k elements in that heap, which is the trick to this question. I will delete that. Hold on, I'll be back.